exothermic and endothermic reactions are two different ways that heat and energy move. So when we first talk about this, we want to make sure we have a good idea of kind of the terms that we'll be seeing. So heat, for example, this is a transfer of energy due to temperature differences. Seems like an overly simplistic idea of heat, but when we think about something heating up or cooling down, it's just energy either being released or energy being absorbed, which brings us to exothermic versus endothermic. So exothermic, for example, this is when energy is released. Okay, so think about some examples. We have fire, we have light. Okay, we're going to be drawing some graphs too here in a second about what those will look like in terms of energy, but that's our basic definition. You could probably guess endothermic. This is energy. This is where energy is absorbed. You might be asking, what is absorbing energy? So say we have a pile of logs and we start burning them, right? So we talked about how fire is exothermic. So here energy is going into the surroundings, right? It's going into the environment or atmosphere, right? So we call that the surroundings. The thing that is part of the chemical reaction, this is our system. So usually whatever that is involved in the chemical reaction, the reactants and the products, that is our system, and everything else around that is our surroundings. So exothermic is when our system is releasing energy, and endothermic is when our system is absorbing energy. And so also when we have basically an exothermic reaction, we also have kinetic energy changing, right? We talked about how before that temperature is basically just the average kinetic energy, right? So this is the energy of motion. More temperature or more heat applied will raise the temperature. More temperature means we have more molecules moving at a faster rate. All right, energy of motion and temperature is a reflection of that energy. Okay, so we'll get to this equation here in a second. That's one on the handout. But let's take a look just conceptually at kind of what we mean for exothermic reaction. So we have some potential energy as our y-axis, and we have basically time as our x-axis. So in a exothermic reaction, we're going to start with our reactants, and they have a certain amount of energy, which is represented by joules or kilojoules, right? So the reactants, we haven't done any reaction yet, but at some point when we do, maybe we combine the products, there's a spike in energy. Oops, that wasn't supposed to go straight to hill, and then it kind of levels off. So this point right here, this is what we call our transition state. This is when the reactants are turning into the products, which we see here at the bottom. Right, and then we can also see that our energy from the system goes down, right? Because energy is released. And let's make sure we have this written down. This is an exothermic reaction. And so energy is released, it's going down, and then the products have lower energy than what we started with. You can probably guess if we do an endothermic real quick. We still have our potential energy. We have time. Now, where do you think our reactant's energy is going to start. So this is the opposite. So this is our reactants. Whoop, oh boy. Here we go. Our reactants are going to start down here. Then they're just kind of sitting, and then boom, reaction, and then products are left up here. All right, and this time, our system has absorbed energy. So our potential energy goes up. All right, and some ways to think about, or maybe some examples of endothermic reactions. So things like dissolving, depends on what you're dissolving. So like ammonium nitrate in water, dissolving that is endothermic because the ammonium nitrate is absorbing energy. We also have things like decomposition. We talked about that in terms of types of reactions when something is breaking apart. So we have mercury oxide, for example. When we give it enough heat, that heat goes into the mercury oxide and it breaks up the two molecules into mercury and oxygen gas. Okay, so let's take a look back. So this is a problem you have. So this is kind of a freebie. We're going to talk about this reaction. So the question reads, I just have in front of me, you mix solid copper sulfate with a small amount of water in a beaker. Hydrated copper sulfate is produced. The thermometer inside the beaker indicates that the temperature has increased from 19 degrees Celsius to 48 degrees Celsius. Okay, so first we want to list all the substances that are part of the system. So in this case, the system is the thing that we are applying heat to. So in this case, this is copper sulfate. Maybe we should do this in a different color. Copper sulfate. And then, so the water is part of the system as well, right? These are our reactants because they are both changing forms of matter. Okay. And then list at least 4 things that are part of the surroundings. So think about the environment that we just did. This is the beaker. Okay. This is the atmosphere, so the things in the air. This is also water that is not reacting with the copper sulfate. Let's see. And then one more thing. We can also think about it in terms of maybe the room, right? Anything, maybe what the beaker is on or the tabletop, something like that. So the next question, which is for letter C, which is at a lower temperature, copper sulfate or copper sulfate with water? Explain your thinking. So the questions or the explanation said that the temperature went from 19 to 48 degrees Celsius. So the surroundings, in this case the water, the surroundings went up. So this kind of goes into letter D too, but this is telling me that this is an exothermic reaction. Right? Because the surroundings are getting warmer. So something has to be released. So what will be at a lower temperature, the system is losing energy. So if we say which one is at a lower temperature, we would say that the copper sulfate is actually going to be at a lower temperature because energy hasn't been released yet to kind of warm it up. So what will you feel if you touch the beaker? It's hot. Burn. All right, it's going to burn because the temperature went up dramatically. And the system, the beaker, has all of the temperature. So E is exothermic, right? Energy is being released. Temperature of the water in the beaker is going up. And then letter F, what evidence do you have that heat is transferred to the surroundings from the products of the reaction? So we have the temperature change. Okay, so this is kind of as a good example of defining systems versus surroundings, and hopefully the rest of the questions kind of flow from that. All right, I'll talk to you guys later.